So here we have to explain the concept of using differentials to find the approximations of certain quantities with some examples. So suppose we have a function y equals to f of x, where it is a real valued function. And so suppose there is a small change in the value of x, which corresponds to a small change in the value of y. So then, so therefore y plus delta y, that will be written as f of x plus delta x. Since I'm saying that when there is a small change in x, there is a small change in the value of x, which is delta x, then that change in x corresponds to a small change in y also. Then that corresponds to a small change in y, which is delta y. So now y is f of x, so I can write f of x plus delta y, that is equal to f of x plus delta x. So here delta x is very small, so it is a small change I'm saying. So it means that limit delta x, so it means that limit delta x tends to 0. So this delta x can be written as dx also. Similarly, this delta y, so since the change in x is very small, it means the change in y also should be very small. So similarly, the limit delta y tends to 0, that can be also written as dy. So therefore this delta y can be written as f of x plus delta x minus f of x. Now if we do delta y by delta x, then that will be equal to f of x plus delta x minus f of x divided by delta x. Now this here limit delta x is tending to 0, and here also limit delta x is tending to 0. It means the change I am saying it is very small. So this can, if I use the first principle of derivatives, then we can say this is equal to dy by dx. So therefore this delta y can be written as, it's delta y by delta x can be written as dy by dx, or it is f dash x, if the change delta x is very small. It means that delta y, that can be written as approximately equal to f dash x into delta x, or we can write that delta y equal to dy by dx into delta x. So this is the rule of approximation which we can use to find the small change in y. For example, so we can understand this concept by using one example. So let's say if it is asked, use differential to approximate root over 36.6. So now we can take the function y equal to f of x as root x. So f of y equal to root x. So now let x equal to 36. So then, and the delta x that can be written as 0.6. So now therefore f of x, which is y is equal to root over 36.6, which is equal to root over x plus delta x. So this is y plus delta y actually, where y will be equal to root over 36. Now therefore delta y that can be written as root over x plus delta x minus root x. Since y we know that delta y equal to f of x plus delta x minus f of x. So therefore this delta y that will be written as root over 36.6 minus root 36, which is 6. Now therefore delta y that can be written as f dash x f dash 36 into delta x. So now f dash 36 means we have to do d by dx of root x at x equal to 36, and that into delta x, which is 0.6. So now therefore the value delta y will be d by dx of root x is 1 by 2 root x at x equal to 36 into 0.6. So that will be 1 by 2 into root over 36 into 0.6. So that is 0.6 by 2 into 6. So 6 into 0.1, 6 into 0.1 is 0.6. So 0.1 by 2, that is 0.05. So delta y is 0.05. Now therefore required value 36 root over 36.6, which is y plus delta y. Now y is root 36, which is 6. So that will be 6 plus 0.05, which is approximately 6.05, which is the final answer. So hope you have understood. Let us solve one more example to understand the concept. So here it is asked, use differential to approximate 25 whole power 1 by 3. So therefore let y equal to x power 1 by 3, and therefore delta y will be equal to f of x plus delta x minus f of x. Now here we can say that x is 27 and delta x is minus 2. So that will be 25 whole power 1 by 3 minus, now therefore y will be equal to 27 whole power 1 by 3. That will be equal to 3. So this minus 3 it will be. Now delta y can be written as f dash x into delta x. So that will be f dash x, that is f dash 27 into delta x, so which is minus 2. So f dash 27, that is d by dx of x power 1 by 3 at x equal to 27 into minus 2. So that will be 1 by 3 nx power n minus 1. So that is x power minus x power 1 by 3 into x power minus 2 by 3 at x equal to 27 into minus 2. So that is 1 by 3 into 27 whole power minus 2 by 3 to minus 2. So therefore delta y that will come as 1 by 3 into 27 power 1 by 3, that is 3. So 3 power minus 2 into minus 2. So that is 3 power minus 2, that is 3 square is 9. So that is 1 by 9. So that is 1 by 3 9s are 27 into minus 2, that is minus 2 by 27. Now therefore the required value of 25 whole power 1 by 3, from here we can see that 25 whole power 1 by 3, that will be equal to 3 plus delta y. So that will be equal to 3 plus minus 2 by 27. So that will be 81. 27 3 is 81 minus 2 by 27. So that will be 79 by 27. So that will be approximately 79 by 27. So 27 threes are, that is 81. So it is slightly less than 3, that is 2.93 approx. So hope you have understood the concept of how to find the approximate values. Thank you.